Okay, so let's start. Okay, so welcome to Anatomy Physiology. This is lecture number 10, and today we will talk about the immune system and the respiratory system. I would like to share you some screen here. And do you see some macrophage trying to hunt bacteria? Macrophage. Let's see. Presente, that is in French. Guichon, guichon. I don't know what to say. The phagocytes. It looks like a horror movie, right? Okay,
Yes.
okay. There you are. Look at this. This is the macrophage. And this is the bacteria. This guy who is bothering the macrophage, see, oh, you're not eating me. I can do whatever I want, bacteria, the bacteria. But the macrophage, see, this macrophage was in the previous was a monocyte, and look at that. The bacteria is trying to play with the macrophage, but bacteria doesn't know what is going on. It's a silly bacteria, I guess. But the macrophage, look at this. What is doing? It's planning. Bacteria is resting. Probably the bacteria is trying to attack the macrophage, right? Look at that. Now it's going to be totally surrounded. So suddenly he found himself trapped. Something is going on. See, the bacteria has been trapped by the macrophage. The macrophage is going to technically eat the bacteria. And then when it's inside the macrophage, they are going to release all the enzymes, destroying the bacteria. Poor bacteria, I'm sorry about the bacteria. But I'm wondering if bacteria have the instinct to escape or something, right? Okay. All right, so that is kind of type of Jurassic Park, but let's continue. Okay, we got it?
Yeah.
Okay. All right, so perfect. So we have here the white cells. You know the white cells, a very common mistake that people, students think that white cells are neutrophils, eosinophils, basophils, monocyte, macrophage, and that's it. No, it's not like that. So it's going, in addition to that, we have the lymphocytes. So a lymphocyte is a white cell, okay? And the lymphocytes are going to have many they have cousins and nephews and nieces and whatever, right? So, and they are going to see, we are going to see the population of the lymphocyte that is our topic today. But before that, we need to go over few things. Just a moment. Okay, perfect. All right. So the B memory cells, we have the lymphocyte B and the lymphocyte T. Let's make a summary. Let's start like this. Okay, so we have the lymphocyte B. The lymphocyte B, why do you think it's called lymphocyte B? Why lymphocyte B? Why lymphocyte T? Why do you think it's called lymphocyte B?
For B cells?
What are B cells? All right, so the lymphocytes B are coming because the lymphocytes B are they are going to born and mature in or within the bone, the red bone marrow. Is that clear? So that's why it's called lymphocyte B. Why they call lymphocyte B? Because they're coming from the bone. They grow, they born and mature in the bone. So in the red bone marrow. We okay with that?
In the bone marrow, you said?
Yes, bone marrow. The bone. That's why it's called lymphocyte B. B as a bone, B as a red bone marrow. Okay? Lymphocytes T are going to be called because these lymphocytes B, they born in the bone, in the red bone marrow, but they get mature in the thymus. Thymus T lymphocytes T. So these lymphocytes T are coming from the thymus. Okay, so they born in the bone, but they get mature in the thymus. And here, the lymphocytes B, they born in the bone and get mature in the bone. Is that clear or not?
Yes.
Okay. So what is the thymus? The thymus is there. Can you see the thymus? The thymus is a gland that is located here behind the sternum, posterior to the sternum. Posteriorly to the sternum is going to be the thymus. The thymus will be located behind the sternum. The thymus will be this long. When you are a kid, it's basically almost the size of the sternum in size, okay? But when you get mature and you get older, the thymus are going to get smaller, okay? Shrink, okay? So, but it's still working. All right, so this is the thymus. So what is doing the thymus? The thymus are going to have, here we have the bone, where they're going to born the lymphocytes, some lymphocytes. These lymphocytes, they go to the thymus and they are going to form the lymphocyte T cell, lymphocyte T, the lymphocyte T, lymphocyte T. Because they born here in the bone, but they get mature in the thymus. So what these lymphocytes T are doing? Okay, so this is very crucial and very important. We was talking previously about autoimmune disorders, and that is basically what we need to talk today to understand that. Thymus. So thymus are going to be, imagine yourself. Imagine that your room, where you are right now, is the thymus. Okay, you are in the thymus. The room that is your thymus is the thymus of your body. Who is your body? Your house. Your house is your body. So imagine, my house is my body. This room is the thymus. And who you are? You are the lymphocytes T. Lymphocytes. Okay? I want to see faces. Okay. Cameras, please. And then, let me see, layout here. See, everybody's here. Okay. Show your camera, please. Okay. Now, you are in your room. You are the lymphocyte T. You okay with that? Okay. So you have a mission. You as lymphocyte T, you came from the bone and you are going to live in the thymus to get mature. To get mature, you need to be trained. And you, as a lymphocyte T, you have a mission. What will be that mission? I want you, as a lymphocyte T, go out of your room and recognize every single object belongs to your body, to your house. So every single chair, you're going to make a tour all over your body. And you're going to have, this chair is mine, this table is mine, this TV is mine, this refrigerator, this kitchen, this cup, whatever you find there, you can recognize that is part of your body. You okay with that? Okay. So now that you already finished the tour in your house, whatever is going to be, for example, another stranger coming to your house, that is going to be considered as an attack because your house is your place. You're not going to, you recognize the people who live inside. But if somebody coming from the outside, you never saw it. You never saw it in your life. So that means that is you consider that an aggression, an enemy. So what you're trying to do is to get rid of that individual. Yes or no?
Yes.
Yes.
Okay. So that is one of the functions of the lymphocyte T. The lymphocyte T, and listen to this is crucial. Lymphocytes T are recognizing every single tissue in your body, cells, tissue. So that's why when you have a bacteria coming into your home, into your body, the lymphocytes T will not recognize them as part of your body. And what they're going to do? They're going to destroy the enemy. ¿De qué vida?
Yes.
So
Yes.
the lymphocytes T are part of the immune system, the lymphocytes in general. So we will talk more in detail. So now, remember we were talking about the autoimmune disorder. Autoimmune disorder, right?
Yes.
Autoimmune disorder like lupus, rheumatoid arthritis, myasthenia gravis, multiple sclerosis, all these that we talked in the past, right? So this is an autoimmune disorder. So that means, listen to this, autoimmune disorder is when your immune system is attacking your own body. How come? How come? You're attacking your own body. So it's like you have your sister, your brother, husband, or wife. You're attacking that person inside your house. So you become like crazy, right? And why is that? Because for some reason that we don't know what is the cause, the autoimmune disorders, the lymphocyte, they lost the memory. They cannot remember who you are. And the lymphocytes are going to think that you are an enemy. So that is what is causing the autoimmune disorders. So the lymphocytes, most commonly, big part or partial or big components of the lymphocytes T cannot recognize your body because they don't know who you are anymore. They have like amnesia. They lost the memory. We okay with that?
Yes.
Okay, so that is the explanation of lupus, arthritis, etc., that we was talking before. Is that clear for everyone? Okay,
Yes.
perfect. All right. So that is the beginning. So it's the thymus. That's why you have the lymphocytes T, because those are the cells who are going to recognize who is your body, who is not. Okay. All right. So let's talk about infection. And for this, let me go here. Okay.
Dr. G, so you said the T cells recognize what belongs in our body, right?
Yes.
And
Yes.
attacks what doesn't belong.
Yeah. And when you have autoimmune disorder, it's because the immune cells, these T cells, are losing the memory, so they cannot recognize you anymore.
And that's
Okay?
just the T cells or the B and the T cells?
Well, we will see that the T cells are the big component of that, and those are basically the commanders. So whatever the B cells are going to be doing is based on the commands of the T cells, and we will see that in a few moments. Okay?
Okay, thank you.
Okay? All right, perfect. All right, so just give me a second. So I'm going to go a summary here, and I'm going to, this is a very nice summary, and we are going to do some complementary things here. All right. So let's, number one, we have the first line of defense. The first line of defense. First line of defense. We have the second line of defense. We have the third line of defense. Okay? Who is the first line of defense?
T cells?
Your skin.
And
This first and second line of defense are no specific. I hate this. No specific. No specific. And the third line of defense is specific. Okay? The first line of defense, no specific, that means whatever enemy you have, doesn't matter the color, the size, the shape, the behavior, doesn't matter. If that do not belong to your body, Nobody, no matter what is bacteria or virus or fungus, A, B, C, or D, whatever, they're not making any difference. So you are an enemy. I'm going to destroy you. But a certain line of defense are the one who are going to be a specific target. So I'm going to destroy only this enemy who has these specific characteristics. For example, I'm going to destroy staphylococcus. There is immune system that are special forces in your body who are going to be a mission. The mission will be to kill or destroy a specific enemy. All right. So just remember one thing here. Let's suppose that we have, I'm going to try to do something. Let's make the United States. This is United States. And the United States, we have defenses, right? We have two defenses. The first line of defense will be the borderline. The first line of defense will be this. The first line of defense. The first line of defense. That is the first line of defense. Okay? The first line of defense. Then we have, if the enemy is able to disrupt, if the enemy is able to disrupt the first line of defense, what is going to take over is the second line of defense. And where is the second line of defense? The second line of defense are going to be inside the country. This is inside the country. These dots, what I'm trying to show you here, are basically bases. Bases. So some confusing? It's not confusing. It's the second line of defense, second line. So when the second line of defense are going to be activated, the second line of defense are going to activate the bases that you have here. What are those? Are the white cells. The white cells. Who are the neutrophils, the eosinophils, the basophils, the monocytes. So those are the white cells who are. I didn't mention white lymphocyte because that is the third line of defense. So the second line of defense is when somebody disrupts the first line of defense, and all what is in your bloodstream are going to run these lymphocytes to kill the bacteria. So I want just to let you know something here. The white cells mostly are living in the tissues. Okay, so if you have, for example, United States have an army, and tell me, all the soldiers are walking on the street? All the army, all the million soldiers that we have are walking on the street?
No, Dr. G, this is
No,
not
right?
cool.
They are going to be in the bases, right? In bases, right? In the military base, right? Military base. So military base are going to be in the cities. The cities represent the tissues. And these cities, they're in the bases, the military base. When you have an alarm, when somebody is invading, for example, the base, military base, if somebody's coming from, let's put it, from California, from the ocean or from the south, whatever, passing the boundaries of California. So the military base who is going to respond is not the one who is in New York or in Florida. The military response will come from areas that are close to California, or no? Yes or no?
Yes.
All right. So mostly all the soldiers, all the white cells are going to live on these military bases, and some of them are going to patrol. Yes, some they're going to keep patrolling the city, but are going to be few of them only. Right. So those are the ones who produce the recognition, to be like a police. Let's put it like police. Police is just basically checking all the cities with some rounds, whatever, right? Travel. So that is how we need to think about the second line of defense. So the second line of defense will be everything that is inside your body. And that basically will be the neutrophils, eosinophils, basophils, and the monocytes. The first line of defense, we mentioned that in the previous class. The first line of defense will be the skin, could be the gastric acid, the respiratory tract, the mucosa with a pH acid of the oropharynx, genital area, etc. Right? So that is the first line of defense. When you disrupt the first line of defense, that is going to go into the second line of defense. There are going to be an alarm, and the military bases on the area are going to release or they are going to send more soldiers to the area. Okay, so the first line of defense will be the skin, will be the mucus of the oropharynx, genital area, right? The eyes are going to be flora. First line of defense will be the stomach, the respiratory tract, the gastrointestinal system, especially the gastric acid. Gastric acid is acid, and that prevent the growth of bacteria. Respiratory tract, you have the goblet cells with the mucus that we talked in the past, pseudostratified epithelium, that produce the first line of defense. Okay? Second line of defense will be white cells like neutrophils, eosinophils, basophils, and monocytes. And the third line of defense, look at this. This first and second line of defense do not discriminate with any type of bacteria. If you are enemy, if the bacteria is any bacteria that your body doesn't know, doesn't matter what type of bacteria it is, A, B, C, D, whatever, the first line of defense are going to protect against that. The second line of defense too. But the third line of defense are these, I will put it here, these third line of defense that are inside the body here. But this third line of defense will be those special forces. These special forces, we have there's some special forces that you know, green hats, I don't know how they call that. Tom, what is a special force in the army?
Green beret.
Green what?
Beret.
Beret? How you spell that?
BERET.
Yeah, that.
Okay. How you call the seagulls? No, seagulls no. But anyway.
Navy SEALs?
Navy SEALs, yeah. Navy SEALs. All right. So those are special forces. These special forces, they have special missions. So they have specific targets. So, for example, I have a specific target for bacteria A, but this is not for bacteria B, only for bacteria A. But the army is going to train people for bacteria B. So that bacteria B, they know how to kill bacteria B, but they don't know how to kill bacteria A. So those are the Navy SEALs. So those are the third line of defense. Is that clear?
Yes.
Yeah.
Okay. Just to know about this, number one, you need to remember that we have the first line of defense when it's being overpassed, the stomach, respiratory tract, etc. And that depends of the virulence of the bacteria. We will see that. How aggressive is the bacteria? So when you said virulence, question for the exam, virulence sounds like it's a virus, but virulence, the term or the definition of virus is how aggressive will be the bacteria, or a virus, or a protozoa. So how aggressive, how virulent you are, how aggressive you are. Right? There's people you can say, yes, homework, say at home, oh, you are too virulent. So that means that you are too aggressive. Okay? Now, so the virulence depends. So remember, virulence is for bacteria. It can be used for virus. It can be used for any organism. So virulence in medicine means how aggressive is the microorganism. You okay with that?
Yes.
Okay. So depends the virulence of the bacteria. For example, if you have 2-3 bacteria on your stomach, so the stomach is going to destroy that bacteria. But if you have, for example, instead of 2 or 3, you have 1,000, the stomach will be taking care or kill the majority of them, but some are able to pass because the dose of the bacteria or microorganism. Okay? So it's not the same to kill 2-3 enemies than 1,000,000 enemies, right? In addition to that, the virulence is going to play a very important role because there is some, for example, let's say bacteria A and bacteria B. Bacteria A and bacteria B. For bacteria A, you need 100 bacteria, just to give an example, to produce a disease. But in bacteria B, you need to have 2 or 3 bacteria to produce the disease. Who is more aggressive? Bacteria B. So that bacteria is more virulent than the bacteria A. So it's a combination of how much of the bacteria you are being attacked with and the virulence of the microorganism. You okay with that?
Yes.
Hello? Everything is clear? So please tell me, please. Okay.
Yes.
All right. So now, saying that, I need to tell you a few things here. One of the first, when you have an infection, means the invasion of the bacteria, all right, or virus, whatever. The first one who deploy in your body. So we already know that the first line of defense is being broken. So the microorganism is already attacking your body, and the first one who deploy, who is that? That is the number one, the neutrophil. The neutrophil. The neutrophil are going to show you that this is the nucleus. This is the way it is, nucleus, and with these granules, right, granulocytes. These neutrophils are the first ones who deploy. These guys are going to kill about 10 bacteria at the same time. So that's what I call, and I mentioned that before, this is the ninjas. I call the ninjas. N as a ninja, N as a neutrophil. They kill 10 bacteria at the same time. 10 bacteria. So it's like you're killing with your foot, with your right foot, with your left foot, with your elbow, with your wrist, with everything you can. So it's a very, very, very brave soldier. So the neutrophil are going to basically kill these bacteria, and they become so crazy about killing. He becomes like a machine, a killer machine. And this neutrophil start to attack not only the bacteria, but it's going to start destroying your own body. It's trying to destroy your own cells. They are so hungry of blood, they are going to destroy their own cells. And that's why the neutrophils commit suicide in 3 days. In 3 days. That is how nature is made this. So in 3 days, the neutrophils are gone. Number 2, we have the eosinophils, that actually those are going to produce killing the bacteria with enzymes. I was mentioned that is like, how you call that? Sniper, right? Remember that or no?
Yes.
Yeah.
Okay, sniper. Okay. So these sniper are going to be elevated. These eosinophils can be elevated when you have allergies, for example. Allergies. The neutrophils are going to be elevated when you have acute infections. Number 3, you're going to have the basophils. The basophils are the ones who release histamine. And we will talk about that in a few moments. Number 4, we have the monocytes. The monocytes are going to turn into macrophages. And monocytes are elevated when you have chronic disease, a chronic disease. Basophils are elevated when you have an inflammation process in the body, inflammation. So we have neutrophils, acute, eosinophils, allergies, basophils, inflammation, monocytes, elevation in chronic problems. Okay? Okay with that?
Yes.
Yeah.
Okay.
Yes, sir.
So now, that is about, we are going to talk about the lymphocytes B now, the lymphocytes now. And we are going to put together everything because it looks like it's like a mashed potato here and there puzzle. So we are going to put it together in a few moments. But I need to give you the main concept first. The lymphocytes. The lymphocytes we have, and that is question for the exam. Lymphocytes B, lymphocyte B, lymphocytes T. So there is two types of lymphocytes B and the lymphocytes T. Okay? The lymphocytes B are going to be called the humoral, because these guys, they like to stay in the blood fluid, like they be on the blood, circulating blood. That's why it's called humoral, all right? And cellular, this is T is cellular, of course cellular, because mostly they are located in the tissues, okay? Located in the tissues, mostly located in they can come out if they don't want, if they want, but mostly located in the tissues. T cells, thymus, T, tissue. B, going to be in the blood circulation. The B, we have the two types of B cells. One B cell is going to be called the memory cells, the B memory cells. And the other one are going to be called the plasmatic cells. The B memory cells are going to be the ones who keep memory of the history of the contact with the viruses. It's like you have like a recording. They are going to record the enemy that is coming to your body, memory cells. Okay, so we will keep it just as a memory, B memory cells. The plasmatic cells are going to produce what we call the antibodies. These are the ones who produce the antibodies. Antibodies, or AB by short, or the other name to call is the immunoglobulin. Immunoglobulin by shorthand is IG, immunoglobulin. So you have IG is the same to say AB. Is we okay with that?
Yes.
Okay. So these antibodies or immunoglobulins, please, if I ask you, you need to answer these. These antibodies or immunoglobulins are proteins. This is a very important thing, because if you are malnourished, you don't have enough food. You are malnourished. You don't have enough proteins. So if you don't have enough proteins, you cannot produce antibodies that protect your body. So that's why people who are malnourished, it's easy to get sick or not.
Yes.
Right? Very good. So what are doing these antibodies? These antibodies, I have a bacteria here. This is bacteria, the bacteria. And what are doing these antibodies or immunoglobulins? They are going to do these marks. They are going to mark the surface of the bacteria. It's like putting this need to, so I don't know you, you put a cross. So these antibodies or immunoglobulins are not going to destroy the bacteria. Question for the exam. They do not know destruction of bacteria. They don't destroy the bacteria. They don't kill the bacteria. We okay with that? So what they are doing so?
No, which one was it? What doesn't destroy the bacteria? The B?
The antibodies or immunoglobulins will not destroy the bacteria. They do not kill bacteria. Okay? So what they are doing, so these antibodies or immunoglobulins, they are going to mark for destruction. So please, open your mind, please. These antibodies or immunoglobulins are not going to kill the bacteria. What they are going to just is to mark for destruction. They are going to put a cross. So they are going to put a flag on the bacteria. That's it, what it's doing. You okay with that?
Yes.
Now, when is marked for destruction, there are going to be other lymphocytes, another lymphocytes, who are going to say, oh, look at this. This guy is being marked for destruction. So now we are going to kill. So the antibodies or immunoglobulins is the same. So please, I'm telling you, antibodies is the same, exactly the same, or immunoglobulins. I don't want to repeat two words all the time. So you understand that antibodies and immunoglobulins is exactly the same. Okay? All right. So these antibodies are going to mark for destruction of the bacteria. Then another T cells, another lymphocytes are going to come and say, oh, this is marked for destruction. Okay, so that is our duty. We need to kill this bacteria. But the antibodies itself are only marking for destruction. Okay? You, for example, you have COVID-19. COVID-19, the vaccine are going to give you antibodies. It has to give you something more current. Or more kind of, you hear a lot, right? You want antibodies? Yes, you want antibodies. Because these antibodies that are being formed by the vaccine are going to mark for destruction the virus when the virus is getting in. So, and when they are marked for destruction, the body, other lymphocytes can identify there. So you are marked for destruction, you're going to be killed. And that is the function of the antibodies. We okay with that?
Yeah.
All right. So what are the antibodies and what are the immunoglobulins? Those are proteins. Okay? Proteins. These proteins are going to have immune activity. So plasmatic cells are going to produce the antibodies or called the immunoglobulins. And these immunoglobulins are going to be several of them. Immunoglobulin G, A, M, E, and D. So game D. So these immunoglobulins are present on the skin, are present in the blood, depends the type of immunoglobulin. Okay, so now we have the plasmatic cells, we have the B cells, and we have the memory cells. Then we have the T cells. The T cells are going to have different groups. One is the T helper that you must remember for your exam is CD4 and for MedSearch. CD4 is called T helper or CD4. Then we have the T killer or cytotoxic. That is the CD8 cytotoxic. Then we have the T memory cells. Another memory cells, similar as the B cells here, but T memory cells. And the other one is the T regulator. The T regulator cell. Lymphocytes, T regulator, T memory cells, T cytotoxic, and T helper. Okay? So please pay attention to this. All right, so now, these T memory cells, basically the T memory cells are going to memorize the enemy in the tissues. These memory cells are B memory cell patrolling, is the humoral, patrolling through in the bloodstream. All right, so how is this going to work? Look at this. The T helper is one of the most important T cells that you need to always Remember. T helper. T helper is the commander. Is the commander. Is the commander. T helper is the commander. T cytotoxic, these are the killers. Those are the killers. The T memory cells is to keep record of what happened of the enemy. So which enemy was having bacteria A, B, C, virus A, B, C, whatever virus. So they keep a memory. So you are prepared in the future to face the problem. For example, remember in America, Indians, mostly they were killed because of the diseases coming from another continent. They didn't have these antibodies. They was not prepared. So the virus was invading without any resistance the body and killing millions of people. Why? Because they didn't have antibodies. But if you have antibodies that is being allocated or being increased with or produced by after the vaccination, you produce antibodies. So you are totally prepared and ready to react fast in order to kill the microorganism. Okay, so what is doing the T helper? The T helper is going to send orders to the T memory cells. The T helper is going to send orders to the plasmatic cells. So the T helper, for example, I will say, I want you to memorize what are the weapons of the enemy. So in order to know, to do some enzymes and other weapons to destroy the bacteria. So that is what is doing the memory cell. And these memory cells are, if you are, for example, you have hepatitis A, this virus is going to give you only one time in your life. Because when you have the hepatitis A, you have like a simple cold, signs, symptoms like that, but your antibodies are already being made it in order to, when you are older, if you have contact with the hepatitis A, you don't have any problem because the body is going to react immediately because they produce the weapons necessary to kill the virus, the hepatitis A virus. So the plasmatic cells are going to receive order for the T helper. The T helper is telling you, you know what? I want you to mark the enemy for destruction. I want you to identify and mark this bacteria for destruction. The plasmatic cells are going to go and identify what is the strange bacteria or foreign stranger that are going to be marked for destruction. And then the T memory cells, the T helper, are going to send orders to the CD8, the T cytotoxic cells. And these T cytotoxic cells are the ones who kill the bacteria who are being marked by the antibodies. You okay with that?
Yes.
Okay. All right. So is the T helper is going to send orders to the memory cells. T helper is going to send orders to the plasmatic cells. T helpers are going to send orders to the cytotoxic cells. T helpers are going to send orders to the T memory cells. And when we start winning the war, we already won the war, the T helper is going to send orders to the T regulator lymphocyte in order to everything said, okay, we won. Everybody go back to your bases, military bases. Everything need to go into normal now. So we don't need to fight anymore. Who is doing that? The regulator T cell. Okay? You okay with that?
Yes.
So now, which of these cells are going to play an important role in the organization of the immune response? Which cell? Which cell do you think is the very important cell, the one who give orders to everybody?
T helper.
T helper.
T helper.
T helper, right? T helper. So is the T helper is the pivot, is the one who said, okay, B cells, memory cells, plasmatic cells, cytotoxic cells, memory cells, regular cells. So everything is under the command of the T helper or CD4. You okay? You okay with that?
Yes.
Now, I want to ask you something. What is, okay, before, I can do that later. So, HIV. When somebody have HIV, what is the problem? Which of these cells are going to be destroyed? What do you think will be destroyed?
T helper.
The T helper. Yes. The T helper is HIV. They are going to attack especially the T helper or the CD4. So if they destroy the T helper or the CD4, what is going to happen? You don't have the commander. You don't have, it's a war without being organized how to fight against the enemy. So that's why in HIV, what it's doing is literally is beheading the immune system, cutting the head of the immune system. How? Killing the T helper. You okay with that?
Yes.
Okay, perfect. All right, so now let's do it again because we are going to go from the very beginning. All right, so now, please pay attention to this because we are going to put together now, okay, everything together. So you have the skin here. This is the skin. The skin, you have an injury here. Injury. 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 I'm going to start from the very beginning, so don't miss this moment, okay? There are going to be injury. This injury, they're going to destroy cells, as you know, right? Destroy cells. This destruction of cells are going to basically release one substance they call the histamine. Histamine. Released by basically the basophils. The basophils, okay? This injury, it could be, for example, a bacteria, or it could be a virus. It could be any organism that is going to get into your cell. So why the bacteria kill cells? The bacteria is like a hunter. Bacteria is hunting your normal cells in order to kill the cells and take all the nutrients that are inside the cells. It's like an animal eating somebody. That is a bacteria. So it's like a wild animal getting into your body, and this wild animal trying to hunt your cells who contain nutrients. All right, so then what happened? They produce the histamine. The histamine, remember, just to bring up your mind, histamine, the antihistaminics, right? Antihistaminic, you have inflammation, correct? Yes or no? So to cut inflammation, you give antihistaminics. So histamine produces inflammation or no?
Yes.
Very, very good. The inflammation, what it's doing is this. You have a vessel like this, and the vessel now become like that. It's going to produce vasodilation. Vasodilation. These vasodilation are going to bring more blood to the area. So if you cut your finger, the inflammation is going to be in your finger. It's not going to be in your ear. Inflammation is according to the location where is the injury or the problem, right? So more blood. So that means more blood, more white cells. That is the moment where you're going to get the neutrophils. Neutrophils. These neutrophils are going to basically are the Marines, the ones who first deploy in the war in order to start killing the bacteria. So we already talked about the neutrophils today and the previous class, so I'm not going to repeat it. All right, so we have the neutrophils. Now, what happened? But not only the neutrophils are going to be attacking, they are going to be especially the monocytes. The monocyte is very important, the monocyte. Okay, so let's do something. Let's think about if you have you are in peace time, and somebody some country create a very new weapon that we don't know what is that weapon. We don't know what is that weapon. So the enemy is coming, and we don't have defenses against that weapon. So that means that that weapon of the enemy is going to kill a lot of us. Yes or no?
Yes.
Right? So the unknown, that is the problem. So we don't know. That's what happened in the colony when people from Europe, another continent, came from Europe to America, and all the people were living here. They was not aware of those diseases because that disease didn't exist here. So there was like an enemy, a person who are being killed, people who are being killed with a weapon that we don't know. We don't know, right? All right. So that was a big problem. So what is happening now? So if you want to, for example, start to protect yourself or create a defense, what you're going to do is to kill kill one enemy or few enemies, and bring it to the lab. So when you kill the enemy, bring it to the lab, you study what is the characteristics of the weapon. You study how is the weapon killing people. So knowing the weapon very well, you will be able to create another weapon who is going to stop the enemy's tool. You okay with that? I'm explaining myself. Hello?
Yes.
Okay. So what happened here? So we have the bacteria destroy the cells, release histamine, inflammation, produce vasodilation, bring more blood, more white cells. They're going to bring neutrophils, and they're coming the monocytes too. Basophils, eosinophils are acting too. Monocytes. The monocytes, when you are upsetting the monocyte is like this. Monocyte is like a fish mouth nucleus here. But the monocyte, when you stimulate the monocytes, they are going to become what we call a macrophage. The first view that we must mention in the previous slide. This is the macrophage. 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 This macrophage. This, excuse me, please. Sorry for that. Okay. Where I am?
Macrophage.
See, everything was erased. Can you give me, please, 6 minutes? I'm going to go upstairs to change the location, okay?
Yes.
We could take a break, Dr. G.
Yeah, let's take a break. Okay, thank you.
Okay.
Okay, thank you.
Okay, sorry for that. We are going to start at 11:05. Okay.
Okay, thank you.
Sure. Okay, so everybody's here, please. Let's continue. Hello, everybody, everyone.
Yes.
Yes.
Yeah, we're here, Dr.
Yeah.
Excellent. All right. So let's recap. Make a review again. Okay. I was saying that all right. We were saying that we have a tissue injury, and that become tissue injury could be a bacteria too. Consider injury bacteria or virus, whatever is coming. What they are going to produce in the cell is to release histamine. Histamine is a substance that is an inflammatory substance. Inflammatory. Is an inflammatory substance, the histamine. Okay? This histamine, what is going to produce is a vasodilation. 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 So that means that it's going to bring more blood. So more wide area, more wide is going to bring more blood. More blood means they are going to bring more white cells. Okay? Okay. These white cells, the first one who are going to deploy, we was talking about the neutrophils. They're going to come to the basophils that produce even more histamine, more histamine, more histamine even. Okay? They're going to bring eosinophils too. That is the second line of defense, plus the monocytes. Okay? The monocytes, when they are stimulated, they are going to be increased size. They are going to be huge cells. This is a monocyte. This is a monocyte. The monocytes are going to turn into macrophage. I was telling you the story of a weapon that we don't know the weapon, and when we use a new weapon, they kill many people. So we don't know because we don't have any defense against that weapon. So what we are doing is to kill one of the enemy to study how the enemy behave and what is the weapon of the enemy. So knowing that the militaries are going to create a new weapon in order to block that weapon who is killing us. We okay with that?
Yes.
Okay. So what is doing this is you have a bacteria. This is a bacteria, and the bacteria is going to be killed by the macrophage. So the macrophage are going to kill the bacteria, and what they are doing in this macrophage? These macrophage are going to go and showing that dead body with a weapon to the T helper. To the T helper. Okay, so the T helper is going to show the piece of the bacteria or the weapon, and the T helper start to study this enemy, the new weapon, and the T helper start to send orders. They are going to send orders to the B memory cells. they are going to send orders to the plasmatic cells. And the plasmatic cells, receiving the order of T helper, they are going to produce immunoglobulins or antibodies, is the same, that are going to mark for destruction. Mark for destruction. So then the bacteria then is being flagged by the antibodies. This is antibodies, immunoglobulin, or AB, whatever you want to call, AB. So they are basically mark that bacteria, they are going to be destroyed. Then the T helper are going to send orders to the cytotoxic cells called the CD8. And the CD8 is going to recognize what is flagged by the bacteria, flagged by the antibodies, and they are going to destroy the bacteria. You okay with that?
Yes.
The cytotoxic, the T helper, in addition, are going to send orders to the T memory cells. So the next time that enemy is coming with the same weapon, you already know by memory cells how to produce that enzyme that are going to kill the enemy. And that is what is doing the vaccine. When you have COVID-19, the COVID-19 vaccine is going to, what is doing is to have a piece of that virus that represents this bacteria, okay, in comparison. So the piece of the virus here, and this piece of the virus are going to wake up the macrophages. All these systems are going to start working. So the macrophages are going to be having an easy fight because what we have is an attenuation of the virus. So it's a virus who is not going to be basically attacking. It's not going to be. It's not going to. Thank you. It's not going to be so aggressive. Why? Because it's like a attenuated virus. So that is the vaccine. So the vaccine, what is the purpose, is to wake up the immune system in order to mark for destruction without giving you the disease. We understand that or no?
Yes.
Yes.
Everybody got that? Okay, perfect. So now, so that is when the vaccine starts to create antibodies, huge amount of antibodies. So if you will not have the vaccine, the virus is coming to your body, or bacteria, or whatever, any example. The virus is coming to bacteria and your body is not prepared, is not aware how to protect himself with that enemy. But the vaccine, what it's going to give you is that you anticipate that problem, and they are going to create these weapons in order to, as soon the bacteria or virus getting into your body, the body is going to respond automatically. And that is how we use the vaccines for. We okay with that?
Yes.
Yes.
Okay. So now, then what happened if you don't have the vaccine, you don't have antibodies, the body is going to start fighting, but in a very weak way. Because listen to this, when you don't have any antibodies, because the virus is new, in this case COVID-19, for example, the body is taking about 2 weeks to create antibodies. It's taking 2 weeks, but you cannot wait 2 weeks, because in 2 weeks probably you are dead. So that's why the vaccines are going to anticipate that, and they are going to produce antibodies ahead of time that you're being exposed to the real virus or real bacteria. We okay with that?
Yes.
Okay. So now, after that, the T helper, that is the pivot for everybody, this is the CD4. Remember, CD4 question for the exam. They're going to make all the organization of that. Then, when the war is being, we start winning the war, the T helper are going to activate the T regulator cell. T regulator. The T regulator is going to be only released when the war is already won. And this regulator cell, what is doing, okay, all right, everybody, all the soldiers, go back to your base, to the military base, and wait until the alarm is coming again. And that is what happened with the immune system. We okay? We okay with that?
Yes.
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 So making another thing here, briefly, we have the macrophage that is going to give they kill one bacteria or one virus, and they're going to send it to the T helper. It's then the T helper who is going to be simultaneously. I cannot say two things at the same time, so I need to say one after another, but these things happen simultaneously. The T helper is going to send orders to the T memory cells, to the plasmatic cells to produce immunoglobulins. Then they are going to send the T killers. They are going to send T memory cells. And then the T helper, when the war is winning, the T suppressor or T regulator, suppressor or regulator is the same. Suppressor or regulator is the same. They said, okay, everybody go to the bases. Everybody already we are in peace. We already finished the war. We okay with that? So that is the way we have the second line versus the third line. This is the third line. Lymphocytes are the third line. Second line will be all these guys. The first line will be the skin, mucus, etc. Respiratory tract, GI tract, etc. Is that clear or no?
Yes.
Yes.
Okay.
Yes.
Okay. Let's do something here. I do activities in the classroom, so that one. This is one of the things that is really not good when we are doing online. Tom,
Mm-hmm.
you are going to be the T helper.
Okay. Tom helper. Okay.
T helper. Okay, who wants to be the bacteria? Bacteria?
I'll be the bacteria.
Who? Shirley? Okay, you're the bacteria. Shirley, you have a hat in your room?
A hat?
A hat, yes.
Yeah. Yeah, let me
Okay.
get it.
Yes, bring it, but no, don't put it yet. Anna, Hina. Okay, so all right. So they're coming late. Okay, so I hope that you understand what we was talking about. Okay, all right.
Sorry,
Okay.
sorry, I had to disconnect because I'm having connection issues.
Yeah, same
Okay.
here.
Okay, Shirley. All right. So Shirley. Okay, so you have the hat. Okay, so Tom is going to be whom? The T helper, right?
T helper.
T helper. Tom T helper. Okay. Shirley will be okay, Tom. Of course. Okay, go ahead. Tom is going to be the CD4. Shirley is going to be the bacteria. All right, so let's see, Nathaniel.
Yes.
You're going to be the antibodies.
Okay.
Okay. Who want to be the cytotoxic, the killer? Who want to be the killer? Okay, rinsing. Can you be the killer?
Okay.
You're the killer. Okay. All right. So let's make it very, very brief because I cannot the whole activity, but it's going to be the basic. All right. So who is the bacteria? is who's the bacteria is Shirley, right? So the Shirley is coming as a bacteria. So what is going to happen? So who wants to be macrophage? Nathaniel, you're going to be the macrophage. Okay?
Okay, I'm antibody and macrophage.
Oh, yeah. So I cannot see everybody. My God. Okay, Alejandra. Alejandra,
Okay.
you're going to
Yeah.
be the macrophage. Okay?
Okay.
All right. So now, the bacteria that is Shirley is coming to the room. Shirley is our enemy. Shirley is our enemy. So who is going to basically take piece of Shirley? They're going to kill Shirley, and they are going to send it to the to Tom, the CD4. Who's going to kill it? Is
Macrophage.
Alejandra, right?
Yes.
Alejandra is going to take is a macrophage. The macrophage go to Shirley, that is the bacteria, and Shirley is being killed as a bacteria. So they take a piece of Shirley and they are going to take it to whom? To whom? To the T helper.
T
Helper.
Who is the T helper?
Me.
Tom.
Tom, right? Tom. Okay. So just remember again, macrophage kill the bacteria. The piece of the bacteria is going to give to the T helper. Macrophage kill the bacteria or virus. They are going to take a piece and show it into the T helper. You okay with that?
Yes.
Now the T helper, once he studied the weapon and all that, they're going to send orders to Nathaniel. Nathaniel is the one who produced the antibodies. So you, as a production of antibodies, what is your mission? The orders are coming from Tom. Tom was sending you orders to do antibodies, right? Tom is the CD4 or T helper. So what is your function, Nathaniel?
Mark bacteria for destruction.
Mark the bacteria for destruction. Now, Shirley is going to put a hat. Put your hat, please. Shirley. Your camera is on? Okay. Shirley is with a hat. And that means that she is marked for destruction. Okay. Then when it's marked for destruction, it's evident. So everybody can see that she was marked for destruction. And who is going to be killed? So now Tom, that is the CD4, that T helper, is going to tell rinsing, you're going to be the cytotoxic.
Yeah.
So you're going to kill whom?
Kill Shirley.
The bacteria. Very
The
good.
bacteria, which is marked. Yeah.
It's marked for destruction. See, that is the game. So what is happening is the macrophage destroy the bacterial virus. They are going to give it to the T helper. The T helper are going to send orders to the plasmatic cells to produce more antibodies. Once the bacteria is marked for destruction, Tom, that is the T helper, are going to send orders to the cytotoxic cells, T cells, to destroy the bacteria who are being marked previously by the antibodies. So that is what is happening. And you need to correlate that when you are doing a vaccination. When you're doing a vaccination, what you're doing is a piece. They're not giving you a living bacteria. Otherwise, it's like infecting you. They're not going to infect you. They're going to take a piece only that is not producing disease of the bacteria of the virus in order to wake up the immune system, in order to make the T helper send orders to the T memory cells, the B memory cells, to the plasmatic cells, to the cytotoxic cells. At the end, when Tom is seeing that the war is already won, you're going to send the order to the T regulator cell, that are going to say, okay, everybody in peace, everybody calm, we won the war, everybody go back to the base, military base. You okay with that?
Yes.
Yes, Doc.
Okay.
Yes.
And that happened with bacteria. That happened with viruses. That happened with parasites. That happened with protozoa. That happened with fungus. That happened with allergies. That happened when you have molds, when you have pollen. It's exactly the same what happened. So you become allergic when you have this pollen getting into your body. It's going to have the same system. So when the next time you're exposed again, your body reacts very much. So that's why we have allergies, this hyperreaction. Okay? So everything starts with the invasion, injury of the bacteria or microorganism that is going to lead into inflammation. This inflammation are going to allow the second line of defense to act first. And then they're going to present the bacteria through the macrophage to the T helper. And then the third line of defense are going to basically be implemented. Okay? We okay with that?
Yes, Doc.
In classroom, I do this activity and I make the macrophage run after the bacteria. But we cannot make run anybody in the online, right? Okay. So is that clear? Any example, any question?
No, thank you. That was a good explanation.
Okay, thank you. Now here we have we have some infection process. Factors involved to infection: the virulence. Virulence, how aggressive is the bacteria or virus. So virulence is not just virus; it's with any microorganism. Virulence means equivalent, translate in your mind, virulence, how aggressive is the microorganism. Aggressiveness. Okay, we got it?
Yes, Doc.
Okay,
Yes.
so talking about bacteria, here we have toxins. Just to review, this is bioscience. We have endotoxins and exotoxins. The exotoxins are going to be the gram positive, and the endotoxins are going to be basically gram negative. The gram positive, this is the bacteria, they have only one wall. And the gram negative, this is gram positive, and the gram negative, we have double wall, double. If you want to kill a bacteria, who is more difficult to kill, the gram negative or the gram positive?
Negative.
Exactly, more difficult to kill, because this is going to have double wall, 1 and 2 double wall. Okay, it's called the cell wall. That is bioscience. Okay, and this one you see here is the cell membrane of the bacteria. The cell membrane of the bacteria, the gram positive are covered by another called the cell wall. Cell wall is not cell membrane. Cell wall is a polysaccharide, cellulose. That is a very good protection with the bacteria. So what is endotoxin and exotoxin? You need to know that the bacteria are a living organism. They eat, they drink, they grow, they reproduce, they pee, they poo, they make gas. Do you do that? Yes. So the bacteria is doing the same. So the excretions, the defecation, the poo of the bacteria are going to be called toxin. These toxins are going to be released by the gram positive. So these toxins are going to be released. Toxin. And that in contact with the cell are going to be destroyed. And the bacteria, then they have a party. They have plenty food because they destroy the bacteria for food. They don't destroy the bacteria for fun. They destroy the cells because they need food from the cells. These toxins are going to be released by the gram positive. Meantime, the endotoxin, that is actually exotoxin here, exotoxin in gram positive, In the gram-negative is the endotoxin. This endotoxin is like a weapon that is in the cell wall. So this weapon is coming with the bacteria, and I'm the bacteria, this is the cell, this is the bacteria, I'm the cell, this is my toxin, endotoxin, is coming with me. I'm not releasing. That's why it's called not exotoxin, it's called endotoxin, because it's coming the bacteria and are going to kill the cell. But this toxin is going to be with the bacteria all the time. So the gram-positive versus gram-negative are much more difficult to treat than gram-negative because the double cell wall. That is bioscience. So go to bioscience and you will review that. Okay? That is something that we already know. All right, so the predisposition. Predisposition means to infection. So predisposition, for example, you have genetically been predisposed to a disease, or you have environmental factors that predispose to the disease. The most important is malnourishment. Malnourishment. If you are not very well nourished, you don't have proteins. You do not have proteins. You do not have proteins. Enough proteins. And who are proteins? That's what I mentioned in the previous lecture, in the previous slides, that the antibodies are proteins. The immunoglobulins are proteins. If you are malnourished, you cannot produce antibodies. So you cannot mark for destruction. If you cannot mark for destruction, what you are going to kill? The bacteria or virus will be making a party. Is that clear or no? Hello?
Yes.
Yes.
Yes,
All
Doc.
right. So now we have the portal of entry. The portal of entry you already know very well. The portal of entry is the same as the portal of exit. So the portal of entry is how you can get the infection. The portal of exit, how you can be contagious to somebody else. Okay? And those portal of entry or exit will be the respiratory tract, the GI tract, the reproductive organs, the skin, right? So those are portals of entry, even actually the portal of exit. So you can be contagious to somebody else. Now, the dose are the number of pathogens. So there are some bacteria, for example, Staphylococcus. If you eat a little bit amount of, like, let's put it, it's studied like 10 to 12 Staphylococcus, your gastric acid will be able to destroy that. So you will not have any problem. But if you eat more than 10, 15, the bacteria are going to be destroyed, only 4 or 5 of them, but the rest are going to survive. And that depends of the dose. Depends of the dose. It's not the same, the body to protect against 10 bacteria than protect you against 1 million bacteria. Is that clear or no? So if you have the same, you have a bacteria, if you have one bacteria attack one person with 10 of them, and they attack the other person with 100 of these bacteria, the person who have only 10 are not going to show disease because the immune system is actually strong in order to kill those bacteria. But if you have much more than that, you cannot you cannot kill the whole enemy. You have limited weapons. You are not a machine, right? And the body is going to be able to eliminate part of that, but the rest are going to survive and attack your body, producing infection. That is the dose. So the number of pathogens are going to be important to be as a factor to produce an infection. The portal of entry is going to be another one. And the other one is the virulence. The virulence. One more time. I don't want anybody to tell me, virulence, what do you mean virulence? Virus? No, I'm telling you ahead of time. Virulence means how aggressive could be a bacteria. Yes, a bacteria. How aggressive could be a virus too. So virulence is not only used for bacteria. It can be used for other microorganisms like other viruses, other fungus, parasites, protozoa, or etc. Okay, we okay with that?
Yes.
Okay. The immune system, we have the immune system is composed by the thymus, the red bone marrow, and the lymphoid tissues. Lymphoid tissues, I will tell you here, the lymphoid tissues. These lymphoid tissues are the one who contain actually lymph nodes. So, for example, we have the tonsils. We have the adenoids. We have the lymphatic nodes. We have the Peyer's nodes. Payer. I'm going to write it down. This is Mr. Verdad. I'd like to ask you about Peyer's patch. Peyer's nodes. The Peyer's nodes are within the intestinal wall. Then we have we are going to have the spleen, of course, the spleen. I forgot to mention the appendix. Okay, so tonsils are these structures that are behind your throat. These tonsils, when you have a cold, are not being inflamed, enlarged. Yes or no?
Yes.
Yes.
Why? Because these tonsils are having a group of nodes, of lymphatic nodes that are concentrated in that area. And it's very strategically located because the air, the pollen, the bacteria, the virus, that is actually the first line of defense too. They are going to basically attack on the entry when the bacteria or virus start to get into your body, trying to do that. So the tonsils are going to be working on that moment. So they're going to inflame because they are going to produce a lot of lymphocytes B and lymphocytes T. It's like a node, like a lymphatic node that we talked in the past, but concentrated. Many lymphatic nodes are located in the tonsils. Okay? The Peyer's nodes. So you need to remember that. Those are immersed in the wall of the small intestine and the large intestine. So, for example, that is important. Why? Because if you eat a bacteria, 5 bacteria, the gastric acid will kill them. But now, if you eat 1 million bacteria or 1,000 bacteria, the body will get rid of few of them, but the rest of the bacteria are going to continue to the duodenum, to the small intestine, large intestine. So the bacteria try to invade by absorption through the intestine. But the bacteria are going to find surprise. The Peyer's nodes are going to do the same thing. They are going to detect them and are going to try to fight against the infection. You okay with that?
Yes.
Okay. So these guys, I put these guys because they are in training. They are training. So for example, I'm going to give you one situation. You have a person who is adult, and the person is very sick all the time. He's sick one time after another, many times. Do you know somebody like that? That's getting sick one after, very susceptible to infections, whatever, get sick very fast.
Yes.
Right? Why is that? Because when that person was a kid, and the mother say, the mother of that person is coming to say, you know what? I don't know why you get so many times sick. You're an adult, you get sick all the time. But when you were a kid, I was taking care of you so very much, so very well, that you didn't have not even one cold. You was healthy. How come you get older now, you get sick all the time? The reason is very simple. Because the mother was taking care of the kid, that is naturally normal, naturally done, so that the baby was trying to put things in their mouth, grab things, and they was cleaning everything, cleaning. Don't put things in your mouth, don't do this, don't do that. Everything without bacteria. So that actually was
making the person have less contact with a small dose of viruses or bacteria. The body can fight with very, very successfully with a small dose of bacteria or viruses. So doing that, taking pieces on the mouth, whatever they do the kid when they're a kid, right? They are going to make a small doses getting into your body, waking up the immune system, preparing your immune system for the future real attacks. So when in the future you are having contact with this bacteria or virus, your body is already prepared with antibodies in order to fight immediately against the infection. But if you are being protecting the baby, that is, well, happened, and no contact with anything, when you are adult, you are not prepared at all. So any bacteria or virus coming are going to produce infection. You okay with that?
Yes.
Yes, Doc.
Yes.
Okay. So, but I'm not telling you put your baby to eat dust or soil, whatever. No, it's a small contact, right? And that is a natural development of the baby. I'm going to go into cycle a little bit, but actually very, very fast. When you are a kid, you have different stages of development. If you resolve the stage for development, you're going to be basically the standard normal person that we want. But if you break down some of these stages, you can start having some habits like smoking, or for example, drugs or alcohol, is different type of behavior. And one of these stage is called the cannibalistic stage or oral stage of the baby. The oral stage of the baby, that is normal. What is the oral stage of the baby? The baby, whatever they have in their hand, they put it in their mouth. Do you notice that? They said, what is this? And they put it in the mouth. Do you notice that or not?
Yes.
Oh,
Yeah.
Right? That is the oral stage. And why the baby is doing that? You need to understand that. The baby is doing that because everything is new for him, for her. Everything is new. So what is this? Oh, wow, blue. And they put it in their mouth. Why? Because with the mouth, they want to know the shape, to feel the shape of the structure, to taste. So that is a way to know the world. And if you cut that, the baby most likely will have a high risk to develop some, for example, smoking or alcoholism. So I'm not going to talk more about that. Very interesting, but definitely you need to allow reasonably, right, to have this contact with the baby. So to play on the floor sometimes with some blankets, whatever, right? So that is games, right? That the baby will be exposed bit by bit. And we need to be very careful on that. So please, I'm not saying that throw your kid on the ground and make that whatever. No, not at all. So there is reasonable. Okay? All right. So we okay with that?
Yes, Doc.
yes.
Okay. So now we have the immune response. We have non-specific defenses or specific defenses. Non-specific, it will be the first line and the second line. The specific will be the third line. The external threats for inflammation and all immune system are going to be, for example, here we have tuberculosis, TB. Here we have anthrax anthracis, that is the Bacillus anthracis, the anthrax, that is a bioterrorism, whatever. H. pylori, we produce gastric acids. We have the hair of the cat, the hair of the dog, right? So we have mold, we have dust, we have mites, we have this pollution they produce. All these are going to be strange structures that are getting into your body. That is going to wake up the immune system. In allergies, it's happening the same. You have allergies to fish, you have allergies to peanuts, you have allergies to earrings that are not gold or silver. All right, so all these are actually participate the same way as we mentioned in the immune system, I will say etiquette. The etiquette is that the macrophage is going to show to the T helper. So this is our problem. So how you resolve it? Let me think. The helper start to do orders, this and that and that and that. And that is for every single disease, for every single virus. So if there is a virus or bacteria that is unknown, your body is totally not able to fight against that for at least 2 weeks. I want you to write down that the antibodies are going to be produced in the first contact. In the first contact, when you never had contact before. COVID-19 was one example. Your antibodies start to be produced in 2 weeks, but 2 weeks is too late. You are dead in 2 weeks. Okay? So that's why we give the vaccine, to anticipate that. You have a small dose, a small virulence of the bacteria of the virus. So the body is responding with time, with comfort, with ahead of time, in order to produce the weapons, to recognize the enemy. Once the enemy is coming into your body, you react immediately. You don't need to wait 2 weeks. That is clear or not?
Yes.
Okay.
Yes.
All right. So we have the non-specific, we have the first line and the second line. First line and the second line. Okay, so we have the inflammation, we have fever. Fever is good or bad?
Good.
It's good, right? Because it's telling us. And why fever is good? Fever, what is the normal value of temperature in the human body? You do fundamentals, right? You need to know that.
98.6.
Huh? 97 to 100. 97 up to 100. That is the normal value of temperature. And this is the third time I'm giving you in this course, the values of the temperature. What is the respiratory rate?
12 to 20,
12 to 20. What is the heart rate?
60 to 100.
60 to 100. Those three things you need to nail it into your mind. The blood pressure go from 90 to 90 systolic, 50 diastolic, up to 120 over 80 millimeters of mercury. So those vital signs need to be known very well. I know you was doing vital signs in the previous week, right? So you must know that. All right, so non-specific defenses will be the first line and the second line. So we already know why it's non-specific defenses. The first line, the second line defense. All right, so we talk about that. Physical barriers. We have the skin. We have the digestive system, the acids, the respiratory system, the cilia and the mucus. Remember the pseudostratified epithelium. Remember the cilia, and remember the goblet cells that produce mucus. The urinary system, the urine flushes, the flow of the urine. So that's why you cannot don't retain urine, because you retaining urine, any fluid, listen to this, any fluid in the body that is not moving can develop into proliferation of bacteria. So in conclusion, all fluids, every single fluid in your body is moving, because the flow is going to inhibit the reproduction of bacteria. Even the fluid that you have inside your eye that is moving is going to exit and produce, exit, produce, exit, produce. It's moving all the time. So, and that is the urine. If you retain urine, the urine is not moving, that can actually produce bacteria. Listen, the urine that you have right now in your urinary bladder, there is no bacteria at all. There is no bacteria at all. The bacteria is going to start invading at that moment that you pee. The first second that the drop of water, the drop of pee is coming out, there is bacteria already in the urine. Okay. In addition to that, if you're retaining the urine, you are promoting the proliferation of bacteria. And remember one more thing: the urine is flushing; it's like a river. So the bacteria cannot swim against the current. They are going to be flushed and get out if there is a bacteria there, right? So, and second, the urine is pH 6. Again, 6 is acid. Acid. So I'm repeating that many times. So that's why the urine is no bacteria, because the urine, normal pH of the urine is 6. The bacteria, they hate acid. Reproductive organs, the mucus of the genital areas, they are going to be very, 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 not very acid, it's going to be acid in order to protect against bacteria. That's why the genital area, the vaginal area, all this is acid. Is acid. So that's why girls, when they want too much actually cleaning the area, you are changing the pH, and that can lead into bacteria infection. So we will talk about that when it's reproductive organs. Okay. Phagocytosis means the eating of the bacteria. So we have the neutrophils produce phagocytosis. Macrophage are going to produce phagocytosis. So these are the eaters, the neutrophils and the macrophage. Macrophage, how important is the macrophage, right? Is important macrophage or no?
Yes.
Because that is the presenting cell to the CD4. Without macrophage, there is no presentation. So the immune system will never know that the bacteria is invading us. So macrophages are important. It's the connection between the second and the third line of defense. What is a macrophage? Somebody can tell me what cell was macrophage before to be macrophage?
Monocytes?
Please, I have 23 students. Only one student can answer. 23, I mean, macrophage, macrophage is monocyte, as you said very well. Thank you. M macrophage, M monocytes. Okay? Okay. The natural killer or cytotoxic cells, cytotoxic is the natural killer, is all right, so all these cells, the white cells, means neutrophil, basophil, monocyte, eosinophils, lymphocytes, all are being produced by the red bone marrow, not the yellow marrow. The yellow marrow is fat. Okay, that is in the medullary canal. Diaphysis, shaft, then compact bone, dense bone. So remember that, right? Okay, so yellow marrow is just fat. It's not part of the immune system. You okay with that?
Yes.
Yes.
Okay, talking about inflammation, please, I want you to remember the 5 cardinal signs, right? The
Yes.
cardinal signs of inflammation. What are those? Please.
Redness, swollen,
Pain.
lack
What else?
Heat.
And loss of function.
Excellent, very good. Now, I'm going to give you more, and this is a review again. But this is important to know and to understand how you can block inflammation. What I'm going to explain you is to let you know how the aspirin, the ibuprofen is working. That is in the future, but you need to know this. Without this, you will not understand why is that happening, and you will be suffering trying to understand things that you should be understand before. And that is what we're going to talk now. All right, so we have the cell. This is the cell. I'm going to do the cell again. Cell. This is the cell membrane, as you can tell. There is a damage of injury here, and that is going to release histamine. We already know, repeated, right? Histamine. But histamine, how the histamine produce vasodilation? Yes or no? Right?
Yes.
Vasodilation. All right. So, but why the histamine produce vasodilation is what we are going to talk today. So the cell membrane is being destroyed. When the cell membrane is destroyed, and you already know that they are going to be destroyed, they are going to activate an enzyme. So the histamine, when they produce in this injury, produce they're going to release histamine to go to the cells, but this one is going to produce they're going to activate I'm going to go slow. Activate the phospholipase. Phospholipase. Simple to remember. What is these cells? What are these structures? Are
Phospholipids.
phospholipids. So they are going to activate the phospholipase. You okay with that?
Yep.
Second, they are going to lead in the formation of arachidonic acid. Arachidonic acid. These arachidonic acid are going to produce, number 3, the leukotrienes. Leukotrienes. You treat when you have asthma. So in the future, you're going to see that. And the other one are the prostaglandins. Prostaglandins. These prostaglandins and these leukotrienes are local messengers. Local messengers. It's like you're injuring the cell, and the cell is asking for help. That is local messengers. They are going to activate the phospholipase, are going to produce arachidonic acid. Arachidonic acid will go to the leukotrienes and produce prostaglandin. What are doing the leukotrienes? Local messengers. That is a call for help. Help, call for more white cells. More white cells. Leukotrienes. Leuko means white. So when that happens, this injury, they produce leukotrienes, and these leukotrienes are like this. Please help, I need more white cells. And the white cells coming from the bases, military bases, and coming for help. The prostaglandins are going to have, and this, I'm not going to forgive you this, you don't know this, please. You need to know this. This is very important. So prostaglandins is a local messenger for pain, for inflammation, for clot, and for mucus. We talked this before, right?
Yes.
Okay. So what happened when you have an injury of the cell? You're going to have local messenger for pain that is going to make you aware that something wrong is happening. So pain is good. They are going to, when you have injury, you cut your finger, you have inflammation. Inflammation is through the prostaglandin that is being released by the injured cell that are going to produce phospholipase, arachidonic acid, prostaglandins. That is an alarm for help. Inflammation produce vasodilation to bring more white cells to kill the bacteria, to fight against the enemy. And prostaglandins is going to, you hit your finger, cut your finger, you have bleeding. And the prostaglandins are going to block the bleeding, producing the formation of a clot. Prostaglandins, making the local, is a local messenger. You okay with that?
Yes.
Yes.
Okay, is that clear?
Yes.
Okay. And,
But Doctor, do you have a question?
oh, yes, Shirley.
I met somebody yesterday and he told me that he was shot like 9 times and that he didn't feel any pain at all.
Shot?
Shot. Yeah, shot.
What? Shot with what? With bullets?
With bullets, yeah. And so like on his arm here, he had like skin grafts. You could see like where he was shot, but I'm assuming he didn't feel any pain because his body went into shock, right?
I don't know. If you have a shot, you have a lot of pain. The pain at the beginning, the pain is not happening. Why? Because you produce some endorphins, encephalins,
Like
like opioids. But after few moments, you start to have intense pain. Somebody broke your bone here before? Somebody have a broken bone?
Yeah.
Tell me, in the first second, do you feel pain or you feel just the crack?
Just the crack.
Yeah, the crack. After that came the pain. Yes or no?
Yes. Yes.
Yeah.
Why? Because at that moment that you break your bone, you feel just the crack, the noise. Why? Because you produce immediately this endorphin that is like opioid, like morphine, natural produced by your body, that is blocking the intense pain. The other that there are several shots. I don't know. I don't know. I don't want to make any probably no. I mean opinion about that because I don't know what is the case. It could be many reasons. Okay, but shot or bullet, whatever is painful, I'm telling you. Okay. Okay, so that is what I can explain you about that. The pain at the beginning is basically none. Why? Because your endorphins are going to be high. Then after that, it's going to decrease. It starts feeling the pain. Okay.
Okay, Dr. G, do you want to take lunch? It's 12 o'clock.
Yes, sure. Oh, interferon. Oh my God, this is very nice. Oh, okay. Let me finish with interferon and fever. So we already talked about interferon. Interferon is something that you're going to give me 1 minute. Interferon is what is telling you interferon? Tell me the word.
Interferes.
Interfere, right? Interfere. That is going to interfere with the attack of the virus or bacteria. What does it mean? Interferon is the communication between white cells. Is between white cells. Communication between white cells. So they said interferon. Okay, so you know what? Between white cells, and these white cells are going to are going to be prepared, alert, or there is an enemy running around. So be careful. So that is interferon. Interferon is going to make aware not only the white cells but the rest of the cells in order to be prepared for eventually an attack. And they are going to increase the number of enzymes, etc., etc. Interferon. Interferon is going to be given, for example, when you have hepatitis B. Hepatitis B, they need to check the titer of virus in your blood. If there is too much, they give you interferon. Interferon is going to interfere with attack, so that is going to lower the amount of viruses of hepatitis B, for example. Interferon can be used for any other situations. Okay, we will see that in pharmacology too. Fever, we already know. Remember, stimulate phagocytes. But that doesn't mean, so please don't lose this question, okay? Stimulate phagocytes. That means that it's not going, that doesn't mean that the macrophage become more hungry. No. Stimulate phagocytosis with fever because fever produces vasodilation even more. So you produce vasodilation with the histamine, and the fever is going to help on the top. It's going to produce more vasodilation. And that is going to bring more white cells, more macrophages, and more macrophages stimulate the phagocytosis. It's going to eat more bacteria. Is that clear or no?
Yes.
Yes.
Okay. All right. So with that, let's have a lunch break. I will see you at what time, Shirley?
12:32.
Okay. All
Or
right.
you want to say 35?
No, that's fine. That's fine. Very good. Thank you.
Thank
Any
you.
question? Any question?
No, thank you.
Thank you,
No,
Doc.
thank you.
Please, I want to tell you, for those who didn't do the advising form or the midterm evaluation, and keep an eye on you. So I'm waiting for you to complete that, please. Okay. All right. Thank you.
I can show you the world, shining, shimmering, splendid.
Oh my God, Tom.
A whole new world.
Now tell me, princess, when did you?
I'm trying to take it out.
I can show you the
I'm trying to smoke
world, shining, shimmering, splendid. Tell me, princess, a whole new world.
You're waking up my neighbors.
Stop.
A new fantastic point of view.
Are we really doing this right now?
Okay, we're gonna hop on to this
Wait,
karaoke.
that
I'm
wasn't
waiting.
even me. That was my best friend, and she heard you guys, so she started. I was like, "Let me put you on speaker."
Tell her that was Tom. That wasn't you guys.
Kenneth, join into this karaoke.
Unbelievable sight.
Tom got it.
We should make it.
Indescribable feeling.
Y'all got me messed up. I was taking a deep nap. I was dreaming about food.
And then it was a whole new world over here.
I woke up to a new world.
All right, hello everyone.
Hello.
A whole new.
Hopefully we can finish today. So, all right, so let's keep moving. Okay, so this is basically what we was talking about. The specific immune defense is going to identify by macrophage. Macrophage is the etiquette that are going to follow the immune system. They're going to introduce to the T helper the bacteria who is the piece of the bacteria or piece of the virus in order to initiate the immune system. Okay, so one thing that I want you to remember is about antigens. What is an antigen? Antigen, please, is anything that is considered a stranger. A stranger. This is colloquially, we can talk, but antigen is going to be AG. Don't get confused with IG or AB. These are the antibodies. This is the antigen is AG. Is that clear? Antigen will be bacteria. You can call it virus, could be a fungus, could be a protozoa or any other foreign stranger body. Okay, we got it?
Yes, Doc.
All right, so now when you have, for example, organ transplant, when you have organ transplants, do you notice that they look for some person who can be compatible to be a donor? Yes or no?
Yes.
Yes.
Okay, and actually, why? Most of these people are compatible who are family or member of the family, right? Yes or no? Right?
Yes.
Why is they can select the compatibility? The compatibility will be basically compatibility will be, for example, those family members, they have similar proteins. If you give whoever, I mean, randomly select somebody who are going to produce a donation of an organ, that random are going to have different proteins. Yeah, we are humans. We have proteins, yes, but there's a slightly difference between human to human. Slightly, very slightly. So that's why you have different color, different height, different size, whatever, right? So there's some small difference. So that's why when you give a donor that is not compatible, that protein produced actually is going to behave as antigen. and that can produce the rejection of the organ. You okay with that?
Yes.
Okay, so we have the cell-mediated immunity are going to be the cytotoxic helper, regulatory or suppressor, and the T memory cells. That is the classification of the T cells. We have the antibodies. The antibodies, we have the humoral immunity, right? So that is basically the B cells, the B cells, the lymphocytes B cells. Antigen antibody reaction. So there's other mechanisms that are going to help to collaborate to the main mechanism. The main mechanism is what we already saw. But there's other mechanisms that are going to be the antigen antibody reaction. So this basically is going to use another substance called a complement. That is like a gluing. It's going to glue the antibody to the antigen. So that is how they get attached, the complement. All right, so I'm just going to mention that. We have the innate immunity, and we have the adaptive immunity, and we have the active or passive. All right, so let's talk about this natural adaptive immunity. So natural immunity, so call that natural immunity. Artificial immunity, that is basically what they're going to do, the vaccinations. Okay, natural immunity is when the person is in contact with small doses of bacteria or viruses that are going to produce and trigger the initiation of the immune system, process. And artificially, it's going to be the vaccination that we explained. Now, I want to go focus here on the passive immunity. Let me see here. Passive immunity. All right. So you remember Mr. Trump? He was having COVID-19. Remember that?
Yeah, allegedly.
Yeah. Okay. So Mr. Trump was actually hospitalized, correct? And he didn't have a vaccine yet. Remember that?
Yeah.
So they was fighting the viral infection with different mechanisms. And one of these mechanisms is this, the passive immunity. So what they was doing is this. Listen, the antibodies are being formed based on the contact that the person was having with the virus. So they are going to create antibodies. These antibodies is going to take about 2 weeks to be formed. But you cannot wait 2 weeks. So what they was doing is to those patients who already had the COVID-19, they knew that they already produced antibodies. So they was taking samples of this blood, and they was taking the antibodies. They was filtering all the elements, and they was taking only the antibodies that that person with COVID-19 in the past was having. So these antibodies, then they are going to be cloned. So they are going to they are going to make them multiply, not like cells, but they are going to make like replicates of these antibodies. These antibodies, then they was inoculated or injected to Mr. Trump in order to start fighting against the bacteria, against the virus, and not to wait 2 weeks, because 2 weeks could be lethal. That is the passive immunity. The problem with the passive immunity is when it's already used, all the antibodies, when all the antibodies are being used already, you need to have more. You need to have more. Okay? So just remember those 2 weeks are crucial to produce antibodies. Okay?
Yes, Doc.
Okay.
Yes.
So now the HIV is a problem because the HIV is going to deplete the lymphocytes T. Which lymphocytes T? The CD4 or the T helper. All right, so I'm not going to talk about myeloma multiple. All right, so multiple myeloma. Multiple myeloma is a cancer of the blood-forming bone marrow cells. So what they're going to do is they're going to, 714. I don't know what is that. Okay. Multiple myeloma are going to basically, they are going to form more cells, but their cells are abnormal. So that means they are not effective. These white cells are like just the name, but they don't have the function. That is, in conclusion, multiple myeloma. We was talking about the rejection of the transplantation. So we already talked about the antigens, right? All right, so let's talk about the respiratory system. So this is very important. I'm going to ask you to give me at least 4 more minutes about this. I'm going to use as a base what we talk in bioscience. So just to let you know here, if you have a tennis court here, if you put all the alveoli, all these alveoli, if you extend, you open these alveoli like a carpet, like a rug, all over, all the 2 lungs, they are going to have an area of a tennis court. Just to you to visualize that this is the area that each individual is having. You have this area of alveoli, and that is the area where you have gas exchange. Okay, all right. So we have here that we have 2 lungs. You can live with 1 lung, but each lung is going to have 350 million alveoli. Alveolus is singular, alveoli is plural. So each lung, 350 million. So that is about the population of United States. So 1 lung here, living all the United States population. And we have another one, another United States with the same number of people. Each people is breathing in and breathing out at the same time. Okay? All right, so we have 350 million. All right, so what is the primary function of the lung? Maintain optimal levels of blood gases to meet metabolic demands. So how much you know already? Maintain optimal levels of blood gases. So it means oxygen to meet the metabolic demands, because the metabolic reactions, they need oxygen. The majority of the chemical metabolic reactions to produce ATPs are going to be based using the oxygen in the Krebs cycle, the mitochondria. Okay? Okay, so this is part of the nursing process. So please, I want you to be careful of that. When you are going to do the assessment of the respiratory system, you know the assessment starts with a clinical history. Clinical history going to be the present, the past, and the family history. Then don't forget ever the laboratory tests. Laboratory tests. Number 3 is going to be what? The vital signs. Number 4 will be the respiratory assessment. So all the physical assessment. In this case, we are going to talk about the respiratory system. The respiratory system, they have 3 phases. The pulmonary ventilation, the gas exchange, and we have the internal exchange of gases. Okay, so how we are going to classify this? Okay, all right, so here we have, this is the ventilation. You need to assess the oxygenation or respiration. Let's put the oxygenation. And we have the gas exchange, the exchange. Okay, so you need to remember ventilation, oxygenation, and exchange of gases. So these 3 levels you can assess by nursing physical assessment. Physical exam, the physical exam, you're going to assess these three things. Number 1, let's go to the ventilation. The ventilation, please, you need, when you're going to say, you're going to check the respiratory system, you need to check the ventilation. Ventilation, you need to check 2 things. The respiratory rate. The respiratory rate is going to be between 12 to 20. More than 20 is abnormal. Less than 12 is abnormal. 30 is already an emergency. Oh my God, battery is running out. Sorry. If I'm going to lose the connection, I will come back. Oh my God. Okay. Hopefully it's not going to. If it's going, I'm going to come back. Okay. Ventilation. Ventilation, you have the respiratory rate. So 12 to 20 is actually normal. 30 or more, that is priority. 30 or more is an emergency. 30 or more, you are going to, when you have two patients who are in bad condition, you select one that is between, you're going to select priority number one, the one who has 30 or more. That is an emergency. I'm not telling you that you're not going to pay attention to 25, but between 25 and 30, because it's more in risk to die. A patient with 30 breathing respiratory rate per minute. Now, respiratory ventilation. Ventilation, in addition, this is number one. Number two that you need to remember is if this is a superficial or deep breathing. Superficial will be like deep. Those are actually ventilation. Ventilation, in summary, is how you move your thorax, your muscles, your diaphragm, your intercostal muscles are going to be ventilation. So you assessing the ventilation. You okay with that?
Yes.
Second, you're going to check the oxygenation. The oxygenation, you're going to check with the what? With the oxygen saturation. Is the oximeter. The oximeter. The oximeter is going to be between 92% to 100%. That is the normal values of the oxygen saturation. So how you check that? With the oximeter. So now think yourself, you're in front of the patient making the assessment of the respiratory system. You have the oximeter, oxygenation. You check the respiratory rate and you check how is superficial or deep breathing. That is the ventilation. Ventilation. And then you're going to do the internal exchange of gases. How you're going to check the internal exchange of gases? With the capillary refill. Capillary refill. Capillary refill. Capillary refill. Capillary refill. You know how to do capillary refill?
Yes.
Okay. You press the nail and the nail become white, and then you release. And how long is taking to come back the redness again? Tell me.
Just a couple seconds.
Couple seconds. 2 seconds maximum. 2 seconds maximum. Equal 3 or more, that is abnormal. Is that clear?
Yes, this is for external exchange.
Internal exchange of gases, intercellular. So that is how the tissue are going to collect the blood, the oxygen. Okay? So there's 3 things that you need to do. The ventilation, the oxygenation, and the internal gas exchange. The ventilation, respiratory rate, and if there's shallow respiration or deep respiration. Then you have the oxygenation, is the oxygen saturation. And then you go the internal exchange of gases, that is the capillary refill. Those 3 things are going to check the respiratory function. At the level of what the oxygen coming in, how you distribute in the body, and how they reach all the tissues in your body. Okay? So for this, the capillary refill up to 2. 1, 2 is normal. 3 is abnormal. 3 or more. Okay with that?
Yes.
Okay, perfect. All right, so now you already know that. All right, so here we have the inhalation or inspiration, and the exhalation or expiration is actually the inspiration, inhalation, exhalation, expiration. So those are basically the movement of the ventilation. Inhalation is going to be the most important muscle. For the inhalation is going to be the diaphragm. You inhale. The diaphragm, when it's resting, is in that shape. But when you are breathing in, these muscles are going to contraction. And when they make contraction, the diaphragm becomes flat, making more space for the lungs. Inspiration. Make sense?
Yes.
Yes.
Okay. So now, compliance. What is a compliance? Compliance is the elasticity of these lungs. It's elastic, flexible. So you can lose the elasticity for when you have a restrictive pulmonary disease. You will see that in med-surg. And compliance is a normal flexibility of the lung. Can you imagine a lung that is hard to breathe in, breathe hard? Because there is a replacement of scar tissue that is called fibrosis. Fibrosis is the same to say replacement by scar tissue. Okay, and when you replace by scar tissue, when you are replacing by scar tissue, the lung is going to lose compliance and you cannot breathe in. There's some pathology, cystic fibrosis, we are going to talk about another time. Exhalation, the most important muscles are going to be the intercostal muscles. The intercostal muscle. Active phase, so that means that, but when you inhale, then you relax. And the lungs are going to basically are going to return to his previous size. So that's why inhalation is active phase and passive phase is going to be the exhalation. Basically, you can make effort to exhale, but it's a forced exhalation. But the normal exhalation, you don't need to do anything. There is no, basically, you're like relaxing. So that is the passive phase. Okay. Talking about the gas exchange, we have the external exchange, that is the oxygenation. That is the gas move through the capillary blood, to the capillaries, external exchange. The internal exchange is between the capillaries and the cell. So alveoli, capillary, capillary, cell. Open eyes, open ears to these heads, please. Okay, some examples. And now, this is part of bioscience. So remember the respiratory system are going to divide into upper and lower respiratory system tract. The lower respiratory tract are going to continue with the lungs. But the upper respiratory tract go from the nasopharynx to the oropharynx to the laryngopharynx, and that's it. All this is the upper respiratory tract. So they go the larynx. The larynx is, this is the larynx. It's including the larynx. Huh? The larynx is included in the upper respiratory tract. Below that, we have the trachea. The trachea is going to continue, and they are going to divide. All below the trachea, including the trachea, is lower respiratory tract. So the trachea are going to have 15 rings, and they are going to be anterior to the esophagus. So the esophagus is running behind. The esophagus is running behind. The esophagus is running behind or posterior to the respiratory tract. Now, the trachea are going to divide it in this point. That is called the carina. Carina. This point is the carina. Why is important about this? When you have cough, it's a reflex. The reflex of coughing. Reflex of coughing means that you have something in the tract that is going to irritate and produce the reflex of coughing. These reflex of coughing are going to be present in the pharynx and in the trachea. But when they reach here, this area on the bronchi, the reflex is going to diminish or be absent. So when you are coughing, you can tell that something is in the trachea here. When you lose the reflex of coughing, that doesn't mean that the patient is better. Probably is worse because there is some obstruction here, and this obstruction do not produce the reflex of coughing. All right, so we have the trachea. They are going to measure about 25 inches no, 12 inches, sorry, 25 inches. Is going to be 10 to 12 inches long, the trachea, are going to divide into the main bronchi. These bronchi, we have the right and the left, right and left, they are going to divide 27 times. 27 times are going to divide 27 times. So each time that is branching is going to be a smaller, and smaller, and smaller, and smaller. Okay? So why is important to know what is the upper and the lower respiratory tract? Why? Because the treatment is different. You have upper respiratory tract, you have sinusitis, you have laryngitis, you have actually pharyngitis, and that is a different treatment. But if you have a lower respiratory tract, mostly are going to be pneumonias, for example, pneumonias, and the treatment is totally different. Okay? Okay?
Yes, thank you.
Yes, Doc.
Excellent. So the nasal cavity, we have the nasal cavity. Listen, when you are going to do a NG tube, NG tube is the nasogastric tube. Do you put already NG tubes?
No.
No, okay.
No, not
When
yet.
you put the NG tube, people make a mistake to put the catheter like this, up. So
You have to curve it.
where you go? You want to go to the brain? No. So the NG tube need to be put it in the nose like this, horizontal. Horizontal. Because it's nasogastric. They need to go to the stomach. The stomach is here. And they're going to go like this. Can you see here? So if you put the NG tube like this, where you want to go? You're going to make it like a tangle there. Okay? I'm going to show you some tips now because time is running, but definitely NG tube is something that you're going to learn in your clinicals. If you have any question, let me know. The nostrils. The nostrils. The nostrils are going to be this area. The nostrils are going to be when you have respiratory distress, you will see that this is like a flaring. This is like moving like this, right? Your nose is not moving like that when you're normal breathing. So they are going to, that is going to be a little bit on this side and then go back again. So it's going to go on back, go on back, go on back. That is, you visualize that is going to be called the nares or nostril. That is going to be the flapping are going to happen when you have respiratory distress. The nasal septum. So the nose basically is cartilage. The tip of the nose is cartilage. Then we have bones. We have a portion of the ethmoidal bone and the vomer. So you don't need to remember those names, but definitely the tip of the nose is going to be cartilage. When you have surgery, plastic surgery, what they are going to do is to remodel the cartilage. Okay? All right, so this is a septum, and the septum is dividing the right from the left nose. Here we have the olfactory nerve. This is the olfactory nerve. This is cranial nerve number 1. That I miss. We need to talk about that. But this cranial nerve is where you have that is coming from the brainstem, and they are going to identify the smells. The smells are going. This is actually mucus. A mucus cover this, and when the particles are coming, the particles dissolve, and when they dissolve, they stimulate these terminal nerves, where you have the sensation of smell. All right, so here we have the mucous membranes. And the mucous membranes start from the nose, are going to go to all the pharynx, okay? They go to the trachea, okay? And they go to the bronchi. So all the lining of the GI tract is covered by this mucus. This mucosa is formed by the pseudostratified epithelium that we already talked in many times. Pseudostratified epithelium. This pseudostratified epithelium you see here, some cells are going to specialize. This one. This cell is called the goblet cell. That is called the goblet cell. This goblet cell are going to produce mucus. Mucus represented in blue here. All this blue, like a wavy ocean, that is the mucus produced by the goblet cell. In addition, the pseudostratified, they have this cilia. This cilia. This cilia is moving all the time, moving the foreign bodies, dust, whatever, pollen, towards outside. Okay? And the bacteria or virus or actually dust, when they go into the respiratory tract, they are going to stay there. They are going to stack there because the mucus are going to be like a swamp. The bacteria is trying to get deeper into your respiratory tract, and that is a mechanism of defense, first line of defense. The mucus are going to slow down the mobility of the bacteria or virus to get it into more deeper areas. And in additionally, at the same time, the cilia that you see I drawing here in line, the cilia, are moving like a broom. They are going to sweep out the bacteria or viruses or pollen or dust that is coming to your nose. Okay? You okay with that?
Yes.
Yes.
So that is what is doing the cilia. This is the cilia. This is the mucus, this area, and this is the bacteria, virus that are moving. So they are moving out. So they are going to basically like a broom, brooming out the dust. All right, so we have the concha turbinate. This is the nasal septum, and this is cartilage, as we already know. But this portion is the ethmoidal bone. Ethmoidal bone. Ethmoidal bone. Ethmoidal bone, as you remember from your previous exams, is that part of the 8 cranial bones. We have 1 sphenoidal, 1 ethmoidal, 2 parietals, 1 frontal, 1 occipital, right? 2 temporal. And we have the ethmoidal bone. So now, this is the bone you see here. This is the ethmoidal. This is bone. And this is covered by a mucus. This mucus is seen here in the top here. So here we have the bone, and the bone is covered by a carpet called mucus, and this produces this concha or turbinate. What is important about this is that here in these turbinates, we have the superior, we have superior, middle, and inferior. They are going to drain. What are going to drain there? All the sinuses. Remember the sinuses? Sinuses, we have 2 frontals, 2 sphenoidals, 2 ethmoidals, and 2 maxillaries. That is already known, okay? And all these sinuses are going to drain into the nasopharynx. All of them are there. They are going, and remember the sinuses are cavities, bioscience, cavities that is going to help to decrease the weight of the cranium and produce the resonance of the voice. Sounds familiar? Okay, so these openings or these cavities on the cranium are going to drain into the nasopharynx. When some of them are being blocked, the secretions of that cavities are going to stay and get infected. And that is called the sinusitis. Another thing that is draining here into the nasopharynx will be the eustachian tube. Eustachian tube is coming from the middle ear. Remember, the eustachian tube is the ear, is not the external ear canal. Eustachian tube is the connection between the middle ear with the pharynx. Okay? So we have the sinuses here. If you see here, this is 2 frontal, 2 ethmoidals. The sphenoidals are behind, couple, and the maxillaries. So all these, if you see here, are draining into the nasopharynx, draining. All of these are draining. When these have some secretions here, if you block because an infection, you block here the drainage, this is going to accumulate, producing what we call sinusitis. This sinusitis is basically pain. You have a lot of pain, facial pain. The largest from all the sinuses will be the maxillary sinus. That is the largest. That is a review. We already talked that in the past. So here we have another view of the frontals, the maxillaries, the sphenoidals, and the ethmoidals. So how you check the patient having sinusitis? So basically they have congestion, and with your finger you touch here, pain, 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 pain. Basically, you can touch the pain here. So, but you can touch the somehow the ethmoidal, you can touch the frontal, and you can touch the maxillary. And you press a little bit, that produces a lot of pain. Mostly people confuse with this one, that is the most common, the maxillary, with the toothache. And you need to be careful with that. So can you see here? Here we have the maxillary. This is the maxillary sinus that is going to drain into the nasopharynx. This is the drainage. All right, so here we have the areas of localized pain. When you touch very gently, you will trigger out a lot of pain, whatever the sinus it could be. Could be one, could be two, could be a pair, could be whatever variation you want, but it's going to be facial pain. Okay. So you can see here, we have, this is going to be the frontal, this is the sphenoidal, and the maxillary is on the lateral, so you cannot see that very well. And they are going to drain into the nasopharynx. Can you see here? Drain, drain. Here's basically the ethmoidal coming here. You don't see there because it's in the ethmoidal lateral and not medial. This is the medial view. In addition to that, what is going to drain there? Bioscience again. If you have tears, that's the lacrimal gland, that is the one who produces the tears. Tears. They are going to be here. This is the gland. So the gland, when you cry, is here, on the outer quadrant of your eye. That is the lacrimal gland. That produces the tears by gravity, go to the conjunctival area here, and then they're going to drain. They're going to drain. So that is called the nasolacrimal duct. Nasal, nose. Lacrimal means the lacrimal, the tears are going to drain into the nose. So that's why when you cry, or when somebody cry, they ask for a paper to blow their nose. Correct? Yes or no?
Yes.
Yes.
Why? Because the tears are going to drain into the nose. That's why it's going to, you need to blow your nose. Well, in that case, because the nasopharynx are going to collect all these elements, the sinuses, the eustachian tube, and the lacrimal canal. There you are. So we have the lacrimal canal. This is the caruncula. People think that the tears are coming from here. No, the tears are coming from this area. So the tears are coming, and they are going to go into this lacrimal sac, go to the nasolacrimal canal, and they are going to drain into the nasal. This is your nose. Your nose. Here's your nose. This is your nose. Okay? All right, so paranasal sinuses, I put it that in purpose, is the same to say sinuses. It's called paranasal because it's parallel to the nose. But actually, those are sinuses too. It's the same. You can mention that as a paranasal or sinuses. All right, so the pharynx, we have the nasopharynx, the nasopharynx. So the pharynx are divided in this: nasopharynx, oropharynx, and laryngopharynx. Laryngopharynx are called sometimes just larynx, but all these three together are called the pharynx. Is that clear or no? All these, naso, oro, laryngo, together are called pharynx. You can call the nasopharynx is because of the nose, oropharynx because of the mouth, and the laryngopharynx is where is the larynx. Laryngopharynx you can call the just larynx only. Okay, laryngopharynx, larynx. Okay.
Yep.
All right, so the larynx is going to be this portion. This is the larynx. This larynx is going to be, this larynx is the last portion of the upper respiratory tract, and these larynx are going to contain the vocal cords. Vocal cords. This, can you see this structure that is called the Adam's apple? That is the thyroid cartilage. Thyroid cartilage. So touch your anal sapo. You're not going to call anal sapo anymore. You're going to call the larynx. That structure of the larynx is going to be composed by many structures. We are going to have the epiglottis. Remember the epiglottis? We discussed that a long time ago. Epiglottis, the vocal cords, and the thyroid cartilage. There's other, the arytenoid and other ligaments. So I'm not going to go on that. But you need to remember that the larynx is composed by the epiglottis, by the vocal cords, and the thyroid cartilage. Thyroid cartilage. We okay with that? Hello?
Yes, doc.
Yeah. This is the vocal cords. This is looking for inside the larynx. This is the larynx. This is the vocal cords. So when you talk, these cords are going to vibrate, making the sound of your voice. The glottis. I want just to go here. Look at this. This is the respiratory tract. And behind this, all this is the bolus. Can you see eating something? This is the bolus. The eating. The bolus is here. So this is this tube you see here, this tube is the respiratory tract. But this tube behind this one, this is the esophagus. So we have here the respiratory tract here, and behind that is the esophagus. On the top of the larynx, listen to this, on the top of the larynx, we are going to have this, what we call the epiglottis. Epiglottis. This epiglottis, when you're eating, this epiglottis is going to close to prevent the food go to the respiratory tract. So remember when I was mentioning when the grandmama said, "Don't eat because you're going to choke. Don't eat and talk at the same time because you're going to choke," right? That's why. And elderly people, the coordination between epiglottis and the closure of epiglottis on the larynx are going to be basically not coordinated. They are losing coordination. That happens in elderly people. The muscles are not behaving as when you were younger. So that's why elderly people have problems with swallowing. You okay with that?
Yes.
Okay. So what is the glottis? Glottis is not an anatomical structure. Why? Because glottis is just a space. Glottis is a space. So epiglottis is this. This is the larynx. This space, when it's open, the space only is called the glottis. The glottis will be closed when the epiglottis is going to close. So there is no glottis when the epiglottis are going, when you're swallowing. So what is glottis? It's like the door. You have the door, your door in your room. The door itself is the epiglottis. The frame of the door will be the larynx. And the space between the frame when you open the door and the door is going to be called the glottis. Is that clear?
Yes.
Okay, so this is some views that you can enjoy that. This is the epiglottis. Let me see. There you are, epiglottis. Okay, so we have the trachea. The trachea is called the windpipe. I don't want to hear windpipe, please. Okay, so windpipe for the patient education, something, right? But between colleagues, between students, you cannot say windpipe, please. It's called the trachea, okay? The trachea is a continuation of the larynx and is the beginning of the lower respiratory tract. The trachea is going to form by different rings, cartilage rings. Well, they're going to be like a U. They're not going to be completely closed because behind that is going to be the esophagus. All right, so here we have the carina, question for the exam. The carina. Here we have the principal bronchi. Remember, these bronchi are going to divide 27 times. 27 times. they're going to divide 1, 2, 3, 4, 5, 27 times until they reach the alveolus. Okay, so we have the bronchi here. So can you see it's dividing 27 times? Here we have the main bronchi, the right and the left. And for that, I need to explain you something before we go to the hilum. All right, so what time is it? Oh, it's already.
1:16.
Oh, I will not able to finish. Can you give me a 1:30, please?
Yes.
Everybody can give me 1:30? And we finish almost. Okay.
Sure.
Yeah, we were going to finish in 10 minutes because the pathology we are going to do another time. This is anatomy physiology. Okay, so, and what is going to be what you are going to love very much, and you don't hate me, please, okay? All right. All right, so here we have the lungs. We have two lungs. Two lungs. We have the right lung and we have the left lung. The right lung are going to have 3 lobes. We have the upper, here, can you see here this line dividing? We have the middle and we have the lower. But in the left side, we have only the upper and we have the lower. So we have upper, lower, but in the right, in addition, we have the middle. So how to remember that? Don't make it confused. 3 is stronger than 2. Just to remember, it doesn't correlate like that. But 3 is stronger than 2. So your right is 3 and 2 is your left. So the right lung, they have 3 lobes, superior, middle, inferior, and the left lung is going to have superior and inferior only. We okay with that?
Yes.
Yes.
Now, what is the term of hilum? Hilum is not only just for the liver, for the lungs. It can be for the liver, for the kidneys, for any entry of vessels. So if you see here, this is the trachea, and the trachea entry the bronchi are going to enter into the lungs through the hilum. What is the hilum? Is this entry. Hilum is the entry door, the entry. We have hilum. Here is going to enter the bronchi, is going to come the arteries, the pulmonary veins are going to come out. The pulmonary arteries coming from the heart here, pulmonary artery divide in 2, right and left. So that is the entry. That where at the level of the hilum, where the pulmonary artery bifurcate into one to the right lung, the other one to the left lung. And the pulmonary veins are coming out from the hilum. Is the entry exit of the elements coming in or out of the lung. We have hilum of the liver. Same thing, the portal vein, the hepatic artery coming into the liver. We have the spleen hilum, where the splenic artery coming in, the splenic vein coming out. We have the hilum of the kidney, where the renal arteries coming in, the renal veins coming out. You okay with that? So every single organ has a hilum. Now, just to finish here is we have the lung are covered by pleura. The pleura. Pleura is covering the whole lung. It's not covering one by one lobe. Is that clear? Don't get confused that. The pleura is not doing this here and here and here. No, they're going to be only a double layer covering the whole scene together at the same time. You okay with that?
Yes.
Excellent. All right, so another thing here that we are going to talk is the alveoli. This is the alveoli. The alveoli, 350 million, as we mentioned already. But the lining of these alveoli are going to compose by 3 types of cells. The type 1, type 2. Okay? Type 1 is a cover. It's like the floor. The floor. It's like, how you call it? It's slates. How you call it? The tiles. The tiles of the floor is going to be the type 1, covering the lining of the alveolus. The type 2 is what you need to remember. That is called the surfactant substance. This surfactant substance, what it's doing is to decrease the surface tension. So what does it mean? Okay, so I need to tell you this. All right, so this surfactant substance, when you have the air in, is going to distend the alveoli. But when you take the air out, the alveoli become like this, collapse. This exhalation, this is inhalation. So when the problem is here, when you exhale, this is like a surface that are very close to each other, and they are going to just attract to each other. So the surfactant substance, if you're trying to do it without surfactant substance, you breathe in, the alveoli will not be open. But if you have surfactant substance, the alveoli is going to be able to open. So that is what is doing the surfactant substance. Surfactant substance is the type 2, type 2, type 2, type 2, type 2, type 2. Surfactant substance type 2. Surfactant substance type 2. Listen, open eyes, open ears. Yeah, so this produces a surfactant substance that is allowing the alveoli to open, just to make it simple. Okay, so why we have babies who are called premature? Premature babies is less than 37 weeks. Why? Because the premature baby premature is premature, before to get mature, premature. So that means if the baby is going to born, at that moment, the baby cannot most likely survive by himself, will not be able to survive. And why he cannot survive? Because the baby, when he's coming out of the uterus at that time, cannot breathe. Why they cannot breathe? Because they don't have the surfactant substance yet. So it's the surfactant substance who determine if the baby is premature or not. So that's why they are going to give mechanical ventilation to help to do that. The lungs are not working because the surfactant substance start to be produced in big amounts, enough amounts at 37 weeks or more. You okay with that? Hello?
Yeah.
Okay, and the last thing I want you to, this is the last thing, seriously. Okay. All right, so this is what you need to memorize for your exam. This is coming, okay? All right, so this we are going to talk about viral capacity, and what we are going to focus today is in the lung volumes. Lung volumes, that's all. So this is probably later. I'm going to talk about lung volumes. The lung volume. What is the tidal volume? Tidal volume is the air that you bring in and out right now. Focus on your breathing. That is already tidal volume. Tidal volume. Tidal volume is going to be about 250 out, 250 in. So you mobilize about half of a liter of air every cycle. And that is what is representing the volume. In, out, in, out, in, out, in, out, in, out. That is the tidal volume. Then when you are going to have this in and out tidal volume, and then you start to have a force inspiration like this, you are doing this. I'm going to exaggerate a little bit. That is normal. And then when you inhale, and then you're still inhaling to the maximum. That is the inspiratory reserve volume. The inspiratory reserve volume. Inspiration to the maximum. Inspiratory reserve volume. That is after the tidal volume. After the tidal volume. Then we have the same thing here, that after the tidal volume, you exhale and you force exhalation to as you can, go like this. Exhale everything you can. That is going to be the expiratory reserve volume. The expiratory reserve volume. Okay? Then we have this volume. This volume is like our oxygen tank. All right? So this volume, we don't use it. This is, we have oxygen here. So that's why you can survive for 1 minute, 2 minutes, 3 minutes underwater. So for example, the sea lions, the whales, the seals, they have this residual volume huge, like a tank. and they can stand below the water like 20, half an hour. So that is the residual volume. So you need to remember the inspiratory reserve volume, the tidal volume, the expiratory residual volume, and the residual volume. Can you repeat with me, please? Inspiratory reserve volume.
Inspiratory reserve volume.
Respiratory
reserve volume.
Second, tidal volume.
Tidal
Tidal
volume.
volume.
Expiratory reserve volume.
Expiratory
reserve volume.
Residual volume.
Residual.
One more time, very fast. Inspiratory reserve volume, tidal volume, expiratory reserve volume, residual volume. Say.
It's
Come on, Tom. You can. Okay? All right, so those are the 4 volumes. So everything ends in volume, volume, volume. You need to know the definition. How to remember that? Who can tell me? Long volume. Long volume.
It spells liver.
Liver. Excellent. Long volume is the inspiratory reserve volume, tidal volume, the expiratory reserve volume, and the residual volume. Liver. You okay with that?
yes, Doc.
All right, so that is the last slide is to let you know about the tidal volume definition, inspiratory reserve volume, expiratory reserve volume, and the residual volume. Vital capacity are going to talk another time. Okay? Okay? All right, thank you.
Thank you.
Thank you.
Thank you, Doc. Thank you so much.
Thank you, Dr.
Thank
G.
you.
Thank you.
Thank you. Tell me, just a moment. Just a moment.